Thanks a lot for inviting me to this inspiring conference. And I'm a little bit sad that I do not see the people who are listening, but maybe I will see them in the chat later or in Gatherworld. I will talk about artificial agents in our social world. First, I will argue that there are socio-cognitive phenomena concerning artificial agents for which we don't have established notions yet, at least not in philosophy. Aiming to overcome our restrictive conception of sociality, I then can sketch a way of how we could conceptualize in between cases. In the last part, I will turn to potential ethical considerations and discuss why we may introduce social norms to regulate our interactions with artificial agents. I assume that we well agree that all the pictures on the right side are examples of social interactions. Similarly, uncontroversial, the pictures on the left illustrated different cases of tool use. But how do we conceptualize the picture in the middle? If you agree with me that not all human-machine interaction can be easily reduced to mere tool use, and at the same time that social interaction seems to require living agents, we do not have notions for such in-between cases. Starting from this terra incognita, we have three possibilities. We can expand the concept of tool use by integrating social features, or we could go for a brave conceptual engineering and introduce a new category. Or, as I will do in this talk, we can expand our conception of social interactions and add non-living agents. From my point of view, there are several reasons speaking for the option to expand our conception of social interactions. Especially regarding interactions with robots, avatars, or chatbots, we can observe a striking similarity to human-human interactions. Furthermore, we know that humans are able to connect emotionally to artificial systems. And last but not least, as we have heard in several talks already, human-machine interactions are used in empirical research to explore human behavior. Therefore, I am motivated to investigate the limits of restrictive standard notions in philosophy and explore this terra incognita in order to conceptualize socio-cognitive phenomena with artificial systems. And what would be more obvious to start with the requirement of a joint action, which is a paradigmatical example of a social interaction. According to Bradman, as you all know, any agent who is able to participate in a joint action has to have the ability to share intention and goals, have specific belief states, and must be able to stand in a relation of interdependence and mutual responsiveness. All this is only possible if there is something like common knowledge, mastery of mental concepts, and very sophisticated mentalization skills. In sum, those demanding conditions are quite restrictive, and that means only humans need to apply. Joint actions with non-human animals, infants and robots are not covered by this notion. And I think the same can be demonstrated with quite a lot of other notions we have in philosophy, like agency, mind reading, and commitment, as you will see in the talk. The fact that we do lack specific notions for in-between cases illustrates our restrictive conception of sociality. It seems like we have no theoretical grounds on which we can account for sociality of non-living beings. However, this might be bound to our Western conceptions. Actually, one should mention that outside Western cultural conceptions, for example in Shintoism or animism, there are conceptions that characterize objects as animate, which from a Western point of view count as inanimate. And additionally, we can observe that even our notion of a social agent has proven to be changeable. Just think about the status of women, children, other ethnicities, and non-human animals. All this makes me quite optimistic about potential changes regarding the conception of sociality. But how? How can we overcome restrictive conception of sociality? I think so-called minimal approaches are a quite promising starting point. Minimal approaches suggest minimal versions of standard notions and thereby capture a wider range of socio-cognitive abilities. By assuming multiple realization, they question demanding conditions and argue that not all conditions which are necessary in the human case turn out to be necessary for other agents. Thereby, they offer a new set of minimal necessary conditions of socio-cognitive phenomena. In the literature, you can already find notions such as minimal mind reading, minimal sense of commitment, minimal action, or shared intention light. Today, I will sketch how to develop a notion of a minimal joint action that is applicable to artificial agents. If we allow a minimal notion of joint action, then there is no necessity for an equal distribution of abilities among participants. For example, looking at developmental psychology, I think it's quite uncontroversial to consider children as socially interacting beings, even though they do not fulfill the criteria of a standard notion. Consequently, joint actions of adults and children are asymmetric joint actions. Turning to artificial intelligence, we can similarly argue that artificial systems qualify as socially interacting entities and consider joint actions of human beings and artificial systems as asymmetric joint actions. This means that artificial agents do not have to fulfill the very same condition as humans. Suggesting a new set of minimal necessary conditions of joint actions, I start here with a rough working definition. I assume that acting jointly requires minimal realization of the ability to act, of course, and to coordinate. Today, I skip minimal agency and just refer to my dissertation, which I wrote years ago, in which I developed already a minimal notion of agency, assuming that biological constraints or in particular, unique human abilities are not necessary. Instead, I will focus on coordination and elaborate on some probably necessary conditions, such as exchanging social information, anticipating behavior of others by mind reading, and being committed. Zooming into the conditions that foster coordination in joint actions. I think it's quite obvious that participants need social competence to coordinate. One aspect of social competence consists in the ability to process social information. will give you an example with reference to Hook. One could describe human-machine interactions as an affective loop, in which artificial systems have to have the ability to process human input, and this includes verbal expression and social cues, and react with an appropriate answer. To what extent artificial agents are capable of doing this is an empirical question, and I think there are many people in the audience who know much more about that than I do. In addition to this more or less general ability to exchange social information, I argue that participants of a joint action should be able to anticipate what the other agent will do next. One major function of social cognition is to encode, store, retrieve, and process social information about specifics, and I think as well as across species, in order to understand others. One important aspect of this ability is the ability to mind read. Luckily, I don't have to develop a new notion of minimal mind reading because Butterfield and Appelai already did this in 2013. According to them, it is sufficient to require from a minimal mind reader to be able to ascribe less complex mental states, namely encounterings and registrations. And furthermore, I think this is quite important for artificial systems. They show that their underlying operations are implicit, non-verbal, automatic, and not based on consciousness. Asking the empirical question of whether artificial agents are able to proceed in minimal mind reading, I can refer to Gray and Brazil. They demonstrated how an artificial agent could model mental states with respect to the perspective of a human counterpart. Succeeding in mind reading, the artificial agent first constructs a model of the physical world, as you can see on the left side of the illustration. In a second step, the human's position and orientation in this model is used to transform incoming sensor data to data that is relative to the human's coordinate system. Thereby, objects are out of the human side are filtered out, and the data is transformed into a human-centric format, showing what a human counterpart can see or cannot see. This human-centric representation can then be used to anticipate future behavior of the human. The third aspect I want to shortly mention is commitment. Commitment can be understood as the social glue for much of what counts as social interactions. It provides security humans at least need to rely on each other, and it does support the success of mind reading. Again, I can refer to an already existing notion. Expanding standard philosophical conceptions, Michael and colleagues who talked yesterday developed a notion of a minimal sense of commitment. Instead of requiring that an agent is only committed if she has assured her commitment explicitly and the other agent has acknowledged this explicitly, they claim that the components, expectation and motivation, of a standard commitment can be disassociated. This means a single occurrence of just one component can be treated as a sufficient condition. And I think this seems realizable with artificial agents as well. Maybe I have succeeded in convincing you that it is possible and reasonable to develop a minimal notion for joint actions which can be applied to artificial systems. In the remaining time, I will talk about potential consequences all this can have for our ethical ideas. Thereby, I will focus on the question of whether there is something like morally appropriate behavior towards artificial systems that could be regulated by social norms. Social norms play an essential role in the organization of behavior in social groups. Besides defining obligations and duties of social agents, they also provide guidelines by attributing rights and values to objects and agents. Thereby, they indicate what kind of behavior towards these objects or agents is appropriate. To argue against social norms regulating our behavior towards certain artificial systems, one has to show that artificial systems are neither moral objects nor moral agents, such as ordinary tools like hammers. If one wants to argue for social norms, one can either argue that artificial systems qualify as moral objects, or argue for the more extensive claim that they can be seen as moral agents. Due to the fact that not all moral objects are necessarily moral agents, as existing social norms regarding our behavior towards non-human animals or nature do illustrate, I claim in this talk that arguing for morally appropriate behavior towards artificial systems does not depend on whether one views artificial systems as social moral agents, even though I have a sympathy for this idea. If we find reasons that show why certain human-machine interactions are worthy of regulation, artificial systems could be added to the list of moral objects. This is, of course, not meant to deny the varieties of human-machine interactions. Of course, there are many interactions which can be reduced to bare tool use. But I want to look at the other side of the picture and argue that there are also cases in which we cannot reduce the interaction to tool use. For some of those, not for all, we have reasons to consider social norms. In the following, I will demonstrate that we should be prepared that some human-machine interactions are not only part of our social life, but also have the potential to change interpersonal interactions. In a nutshell, my argument goes like this. If we can observe a transfer of behavior practiced originally with artificial agents to other contexts, then it's possible that this transfer can make violations of social norms in between humans possible. This is how behavior towards artificial agents becomes a moral dimension, and this could motivate us to consider social norms regulating our behavior towards artificial agents, because this can prevent cruel misbehavior among humans. In the following, I will show how social human-machine interactions make human-machine interactions morally relevant in the view of human-human interactions. First, I will investigate what factors contribute to possible transfers. Due to our ability to generalize, we are able to apply behavioral patterns learned in a particular context to a wide range of situations. And this means that also behavior practiced with artificial agents can be transferred to other contexts. To illustrate this, I will tell you a very short anecdote about Alexa. A friend of mine gave Alexa as a present to his mother, a distinguished British lady, and this older woman treated her Alexa with particular politeness because she was afraid that she would lose her politeness towards humans if she would not do so. Another factor is our tendency to anthropomorphize. People tend to act according to social norms with regard to certain artificial systems. Such moral concerns regarding behavior towards certain artificial agents make those interactions somehow more similar to human-human interaction, and this makes it more likely that we transfer behavior. Somehow, we cannot help it but react socially, even though if our philosophical notions may tell us that our counterparts are not really social agents. Kate Darling reported that even her team members, who definitely knew how the robot was constructed and that it was not alive, were, after a phase of interaction, very reluctant to behave destructively toward this toy robot called Cleo, which you can see on the slide. Last but not least, social robotics reflects on such factors, which I mentioned now, while they develop properties of artificial systems. Similarity to human-human interaction is a desired goal, since it is important because it is an important objective of social robots that artificial systems should enter the human space of social interaction. It is not surprising that specific human-human interactions serve as models. To be successful as social interaction partners, research is being conducted to ensure that artificial systems have specific recognition systems, reasoning mechanisms, and the ability to initiate action. And this includes the ability to interpret social signals as well. All this can foster desirable transfers. For example, interactions in virtual reality can foster skill transfer. Quite successful are, for example, therapeutic settings using virtual reality for the treatment of phobias. And also, pilots profit from the skill transfer gained in a flight simulator. Regarding interactions with social robots, one can report that people with dementia profit from interaction with Paro, a robot seal, which you can see on the slide as well. They seem to find it easier to open up to other people after having interacted with this cuddly animal. But there are also disastrous transfers possible. For example, interaction with sex robots promote the ubiquitous idea that even living women are sex objects, and thereby such interactions contribute to increasing physical and sexual violence against women. And especially shocking to me is the existence of so-called pedobots. Even if there are not yet sufficient studies, it seems obvious to experts that such interactions lead to a lowering of the inhibition threshold, which makes it more likely that real children are attacked. So, where are we? If we notice that our behavior towards social robots can have a negative impact on our interpersonal behavior, this behavior gets a moral dimension. And then we should be motivated to think about whether we should regulate this behavior before it can be transferred. Or, as Kate Darling formulated it, one reason why humans might want to prevent the abuse of robot companions is to protect social values. This means that even if the actual behavior towards artificial agents as machines is usually not morally evaluated, it can get a moral dimension by the possibility of a transfer. At this point, one may object that another option could be just avoid the transfers. To react on this, I have to explain why I think that avoiding such transfer is rather difficult. Of course, if humans would be able to suppress such transfers intentionally, we would only need social norms that mark unwanted transfers as unacceptable. And indeed, I have to admit that humans seem to have the ability to suppress transfers, at least inside human societies. Many behavioral rules in human societies are specific to distinct social roles. It seems natural to people to behave according to the specific social role of their counterpart. Typically, we greet family members differently from work colleagues or other people. But I think there are pronounced characteristics which help us to differentiate people in a human society and not use inappropriate behavioral patterns. What helps us here is that the role in human groups is somehow distinguishable. In contrast, artificial agents are designed to appear as similar as possible to human counterparts. Because of their built-in similarities, artificial systems behave as if they were human counterparts. There are no pronounced characteristics supporting fine-grained differentiations. Certain human-machine interactions are strikingly similar to already well-known human-human interactions. And this is why I conclude that possible mix-ups are almost pre-programmed. So, first conclusion. If you agree with me that, for example, destructive behavior towards nature cannot be classified as morally uncritical, you may also agree with me that neither moral agency nor suffering capacities are necessary for counting as a moral object. Consequently, destructive behavior towards artificial systems cannot in principle be seen as morally uncritical. Following a consequentialist strategy, one can claim that certain artificial systems may qualify as moral objects without having the capacity to suffer or being a moral agent. Future research should provide a deeper analysis of the factors supporting the transfer of behavioral patterns. That means one should deliver a detailed assessment of the risks regarding transfers of concrete artificial systems. Furthermore, we should investigate how such risks might be reduced and investigate how this knowledge may shape our future construction of devices of social robotics. For example, in reaction to parents' complaints that their children unlearn polite language like using please and thank you while interacting with devices like Alexa, at least the advertisement of the new Echo.Kids edition emphasized that not now this device is giving children positive reinforcement when they say please and thank you. Now I will end with a short summary. This talk argued for the claim that some human-machine interactions are rather like social interactions than tool use. This motivated me to think about how we can meet the challenge to overcome restrictive conception of sociality by establishing new notions, which I did along the notion of joint action, assuming that there are social human-machine interactions. I then explored potential consequences, and this led me to my second claim, namely that specific social human-machine interactions can have an impact on human-human interactions, and that this motivates us to consider social norms regulating our interactions with artificial agents. Thanks a lot for your attention, and I would be happy to meet you in Gather Town in the following coffee break. Just an instruction how you can find me. Just click on the participant icon, find my name, click on it, and then you can either locate me on the map or automatically follow me, which will lead you to the place where I am, and I will be somewhere near the fountain. Thanks a lot.
Well, thank you very, very much for this very interesting talk and the quick introduction to Gather Town. We do have some questions and a little bit of time left, so I would like to post these. And if you then, depending on how many we can answer, there might be some left which you can find on the YouTube channel if you want to answer them there in the chat, or the people asking them can find you in Gather Town as you've just described, and I'll get back to that in a moment. But first, a couple of questions for your talks. One of them is whether you could point out studies regarding the negative consequences of deploying sex robots. While it might sound intuitively plausible, people would be more interested in further empirical proof.
I could easily put them on the whiteboard of your interactive channel in the social bridge. There are several studies mentioning that. And of course, in my talk, I didn't really prove it. I just rely on the assumption that it is an at least probable consequence.
Perfect. I will point out later where the whiteboard can be found, but that will be the perfect place for something like this. Do you think that the way we conceive of artificial agents may change how we use or interact with them behaviorally? For example, how we interact with a chatbot might change depending on whether we see it as a tool to obtain information or a social interactive agent. And if yes, could we look at our behavior to determine whether we conceive of them as tools or as social agents?
I mean, I'm not able to really look in the future. I can just share what I think is probable. And I definitely do think that our behavior towards artificial agents, especially towards devices of social robotics, will change. It will get more normal, and it will get less less canny. So at the moment, many people still discuss the thing that it's strange to be cared of by a care robot. But I would assume if I'm getting 80 years old, having a care robot is not that extraordinary anymore. And this will change our behavior, and this will even make my considerations more important, because the more interactions we have, the more similarity we may experience. And if we not start to sort of learn how to build in pronounced characteristics, which make it easy to distinguish between, that was my care robot, or this was my daughter, then we will end up in a difficult situation. So in the end, I'm not really fighting for social norms. I would rather fight for the ability of the human to distinguish artificial systems from humans better.
I was actually thinking about a very similar question, but from a slightly different perspective. And that is whether the way we view artificial agents, so whether as social interaction partners or as tools, might also depend on our own knowledge in the area. So for example, for me as doing research in machine learning, I would assume probably that for me it would be for a much longer time more a tool than a social interaction partner. Or do you think that might be wishful thinking at this stage?
To be honest, I think this is wishful thinking. I mean, just look at the thing I mentioned by Kate Darling. So this experiment was only with team members. There were people who really knew this is a machine. They built it, they programmed it, and they had about 20-minute interaction time. And then Kate Darling came into the seminar room and said, "Now you have to capitalize. So take the head off of Pleo," and nobody was able to do that. And so I think this shows that even knowledge does not help us that much. So we need some research what implicit characteristics may inform us of the difference. If we are already triggered by our tendency to anthropomorphize what we do and what is a nice feature and maybe even a reasonable feature, then it's too late.